Hi everyone. So today we're going to continue with our logs, exploring some other things that we can do with logs and how to evaluate them with a calculator. So if you have a calculator near you or you have a calculator on your phone, you can take that out right now and make sure you have it near you. And I'll tell you guys how to find logs using your calculator. So far the types of logs that we've been doing is just try to figure out how to use logs, the properties of them, how do we combine them. So let's give us an example. If I say log base 3 of 9 is equal to what? Right? And we ask ourselves, what do logs solve for? Logs solve for exponents, so this is going to give us an exponent. So what exponent of 3 would give you 9? Circle of logs. If you want to rewrite this, we can write this as 3 to the x power equals to 9. Circle of logs, where this would be x. But I'm not writing x there because we're just going to go ahead and solve it. So what exponent of 3, how many 3's will give you 9? You're probably thinking, Mr. Ko, this is a dumb question, and that's going to be 2, right? Not 3. It's not 3. This isn't 3 times 3 is 9. This is 3 to the second power equals to 9. So logs solve for exponent. It's helped us define what the exponent would be. We had a couple of special logs here. We had something called a common log, where if I just write log of 100, what would this be? Well, if you remember, a common log, this is an invisible 10. So how many 10s would it take me to get to 100? Same answer here. It's going to be 2, right? So logs solve for exponents, right? So we also have a natural log, something called natural log of e, right? So natural log in general. Fine. This is equal to 1 because log base e of e to the 1 exponent gives you back e to the 1 exponent gives you e. That's a way of thinking about it. So logs help us solve for exponents. Okay, let's continue this conversation. But what if I gave you a value that doesn't work? And we've also done examples like this, so this is kind of repeating, but this is called, let's say this is first, log, how many 3's would give you 10? And is that possible? We know that 3 squared is 9, and we know that 3 cubed is 27. So 3 to what exponent gives us 10? It's going to be someplace between 2 and 3. Because 2 and 3 are whole numbers, so x has to be someplace between, so it has to be a decimal, right? You're just kind of stuck there. So what decimal would that be? Well, we could start guessing. On a calculator, we could start guessing. But we have a way of doing this straight on the calculator, and it's called change of base. Now, you might have, depending on what calculator you have the option to just type it as it is. You might look at your calculator and you have a little button that says log box. Or it might say log XY, something like that, okay, with variables, or log AB. If you have that button, try that button right now, okay? You're going to type log. It's going to give you a little box on the bottom. You're going to write the number 3. You're going to hit the arrow over and write the number 10. This will give you some answer for you. Great. So I don't have that calculator with me right now, but we could do that. But what if you don't have this calculator? Well, we have something called change of base now. Change of base. And I often consider this like a calculator log. It allows me to plug in a log with a base that isn't in my calculator. My calculator doesn't have that base. Normally, calculators only have 2 types. They have a natural log and a common log. Some of you guys might have a log base too. If you look at this Apple calculator here, let me go ahead and find it. If you look at this Apple calculator, where is it? Oh, where's my logs? Here's my log. See, if you'll see log 2 and log 10. They also have natural log here. But that's this calculator. It's kind of uncommon, to tell you the truth, to have a 2 there. So I'm going to have to use the log that are given, either log base 2 or log base 10, or natural log. Now, here is the rule for change of base. You can write any log as a division of logs, log of 10 divided by log of 3. Now, if you did this in your calculator and you were able to write log base 3 of 10, go ahead and type in the answer for me on the screen in the chat so I can just check that. If you didn't, and you have a regular calculator like mine here, you're going to type in literally what it is. You're going to type in log 10 divided by log 3. But again, these calculators are finicky and you have to know how to type them in. And here's what happens. Once I type in a number, 10, I don't type log first because these cheap scientific calculators do the operation to what's on the screen. Now you can see the number 10 is on the screen. If I hit log on that, that'll give me 1 divided by 3 log is 0.477. Now, I honestly do not want to write this because this decimal actually goes forever. So here's what I'm going to do. I'm going to write 10 log divided by 3 log equals. So if I type this out in my calculator, looking at the buttons I'm pressing, 10 log it, then divided by 3 log it, equal to combine them. I'd rather type that. So this is 10 log divided by 3 log equals, and we end up with our answer 2.095, blah, 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 going on forever. I should round up to around 6, okay? 2.96. I'm going to write that a little nicer. 2.96, 2.096. And we said this number was going to be between 2 and 3. And if I write 3 to the 2.0959032742898, we would get approximately 10. Circle of logs. Now, this is why logs are useful for us, because they help solve for exponents. Whatever the exponent is, we can use it to find what that decimal or whole number value would be. Okay, thank you, Brittany. And see, your answer and my answer are pretty much the same. So whether you have a nice button on your calculator that does all the work, great. You probably spend an extra $1 on that. Not bad. It's like having automatic seats in your car, right? You could just use your hand and just push yourself forward and backwards, or you could, have the machine do it for you. Okay? So here is something I need to point out. We went from a base 3 to a base 10, a common log here. But it could have been anything you wanted. It could have been anything you wanted. What if I want to change this to our other log here? We have a natural log here. What if I try log base 3 of 10 as natural log of 10 divided by natural log of 3? Would that give me the same results? Try it. Do 10 natural log divided by 3 natural log. Everyone try that. Just I want to make sure it sits in your brain that it doesn't matter which log I choose as long as they're the same log. And this is also why we call it change of base, because you can change it to any language you want, to any log you want. So if I type 10 natural log, right? That's not a nice 1 anymore, divided by 3 natural log equals, oh my gosh, it gives us the same 2.0959. Okay. So the idea here is that we can change it to a base that works for me. Maybe I want to change this to a base 5 instead. We want to change a common log to a different base. You can do that. Like what if I start off with a log of, let's say 5 here, okay? And I want to change this to log base 5. Sure, you can do that. Log base 5 of 5 over log base 5 of 10. Why did I have to write a 10 there? Because hopefully you remember, when I don't write a log, it's always an invisible 10. It's always an invisible 10 here. And these answers would have been the same. 5 log base 10, it's 0.69. But if I take my route on the right, 5, okay, now the problem is I don't have a log base 5 on my calculator, do I? So I'm just going to write this as just a thought idea. Log 5 over log 5 over log 10 over log 5. Why do I have to do this? Because I don't have log base 5 on my calculator. I don't have that. So I'm going to change the base again, just so I can get that answer. Now, real quick here, we could do this, but you can see, doesn't that divide out to become 1? Okay, so you would type, some of you guys have, when you guys type natural log gives you parentheses, you can just type directly 10 as you see it. You can type it directly as you see it. Then you can type divided by natural log of 3. You can type it as you see it. Hey, sorry, I forgot about the third type of calculators that are even just as special. You can type it if you use the open parentheses, just go ahead and type the 10 after the log, not before the log. Now, let me ask you, going back to logs here, what would my answer be here? Log base 5 of 5. What's the exponent of 5 to get you back to 5? That exponent would have been 1, right? Wouldn't this have been 1 already? Well, this is also equal to 1 here. Now, the bottom part, I'm going to take log base 10. 10 log divided by 5 log. And that gives me, oh yeah, so this is 1.430767. And then we're going to divide this by 1. 1 divided by, let's see if I can do it. Memory, this answer here. Copy result, do it. Oh, come on. Oh, darn it. I was hoping I could just take that. Oh, it did work. Yeah. All right. And we end up with the same answer, 0.669897. Okay. So it's our same answer. Of course, this is like, why would you do that? But the idea is here that what if they asked you to change your base? What if they gave you what that would be? Okay. There are some problems, like when it comes to SATs, they may tell you log base A of 5 is 4. And then they'll tell you log base A of 6 is 3. I'm making this up, okay? Just making this up. What is log base 6 of 5? Okay, so they're giving you this, and they're asking you to find this. Well, change of base is log base A of 5 over log base A of 6, which is just 4 over 3. Okay, so they might give you some givens, and then you're going to have to rewrite it so then you can use with their givens. So change of base is pretty easy to use. Now, the rest of your work today is really just using your calculator, practicing it. They'll give you problems that they'll say, hey, what is log base 5 of 7? And you're like, I don't know. And if you have a calculator, sure, work it out as, if you have a nice calculator, just go ahead and write that. But I want you guys to also please practice writing as a change of base. And remind yourself, this can also be any log you want. Okay, so you can change that log, and all these will give us the same answer. 7 log divided by 5 log equals, okay, 1.209. 7 natural log divided by 5 natural log equals 1.209. Even if I do log base 2, 7 log base 2 divided by 5 log base 2 equals 1. See, the point is that it doesn't matter what the base is when I do change a base. You can change it to whatever form you want. How do you get 4 over 3? For the last problem here, I said this was given, and without a calculator, the idea, this is no calculator. I'm making this totally up, okay? Because log base 6 of 5, and type it on the calculator won't give you 4 over 3. I'm just using this as an example. What if they give you this question here, and I say, hey, using these given values, how would you solve it? Well, change a base. This is really log base A of 5 divided by log base A of 6. This was 4, we said, and this was 3, given these values here. Okay, the last thing on your IXL work, you guys have 3 today, and they're all up to Smart Score 80, is to identify the property. And since we just worked on the properties about a product, quotient, and power rule, that's what they're going to have you work on. They're going to just ask you to decide which property it is. Okay? And that's it.